Hello friends, myself Dr. Nandakumar Raubawale from College of Engineering Ambazogai is going to deal with numerical methods in mechanical engineering. So this is our 8th lecture. In previous lecture we have seen the Newton Raphson method and the problems to solve using numerical method. Now today we are going to study one of the function which is a trigonometric function, transcendental function, and to find roots of such transcendental function, and after that we are going to see the numerical solution to algebraic equation, introduction to numerical solutions to algebraic equations. Now let us see the function f of x is equal to x sin x cos x. Start solution with x is equal to pi, and here the true value of this function, true root of function x t is given, say 2.798386 So this is true root of this function x of t, which is given in the problem. Now we want to simplify this. So while simplifying this, what we should do is we have to differentiate this function f of x. So f dash of x, differentiation of x sin x, first function as it is, differentiation of sin x is cos x, plus of second function as it is sin x, and differentiation of x is 1, plus of, so this cos x, differentiation of cos x is sin x minus sin x. So minus sin x plus sin x gets cancelled, and we get x cos x as the differentiation of given function f of x. So this is equation number 1, which is original function, and this is the derivative of function f dash of x. So now to proceed with this, so we have to find out this function value at x is equal to pi. So it is given in this problem, start with x is equal to pi, and the true root of this function is given as 2.79838604, and differentiating equation number 1, we get derivative of that as f dash of x is equal to x cos x. So now we'll start to solve this. So let us see, this is the function f of x is equal to x sin x plus cos x, derivative f dash of x is equal to x cos x, and xn plus 1, or a revised approximation, is equal to x naught minus f of x divided by f dash of x. So this is what we have to do is, first f of pi we want to find out. Pi in the sense, this is the value of pi, here we take as 3.1416. so here first of all, this is 3.1416 sine 3.1416 cos 3.1416. So convert your calculator to the mode of radian. Usually it is going to be in degree, DEG. So now you have to convert it in radian, RAD. So mode of calculator to simplify this equation must be in radian, because we are substituting angle in radian. If we are substituting it in degree, then we can keep it in DEG. So here converting this into radian, so we get this as minus 1. So f dash of x, so this is x is equal to again 3.1416 cos of 3.1416. So this works out as minus 3.1415. So on substituting this in this revised approximation x0 value we are going to assume as pi. Pi means it is 3.1416 minus of, in numerator minus 1 and in denominator again minus 3.1415. On simplification, this revised root of this equation we get as 2.8233. So these values we can substitute in this table. The function value we are going to the root, approximate root, first root we are going to take as pi, means pi value is 3.1416. so function value we get as minus 1, and derivative of function we get as minus 3.1415, and revised approximation we obtained as 2.8233, and first approximate error we can't find, so true error can be obtained. So here true error is equal to, so we know the true value and approximate value. So first approximation is known, so true error is equal to, true value is 2.79, first approximate value we take. So to find out true error, first approximation is 2.8233 minus of true value is 2.798386 whole divided by 2.798386 into 100. So this we get as 0.89%. So on multiplication of this we are multiplying with 100, we get 0.89 as the true error. So this true error we can write it as 0.89%. So now this revised approximation we write here 2.8233. Substituting this 2.8233 in this function, 2.8233 in this above function, we get f of x as 2.8233 sine 2.8233 plus of cos 2.8233. So we get this as minus 0.066. On substituting this in f dash of x, so x value is again 2.8233 cos of 2.8233. So on simplification, this works out as 2.6814. A very important thing is you must convert mode of that calculator into radian, not in degree. Then a revised approximation xn plus 1 we get as, so previous approximation is 2.8233 minus of, in numerator and denominator both are negative, so this is negative, this is negative, negative becomes positive. So 0.066 divided by 2.8233. So revised approximation we get as 2.7987. So we substitute these values in this table. So this is going to be minus 0.066 and this is going to be minus 2.6814, and this revised approximation we get as 2.7987. Now approximate error can be obtained. So as we know, previous approximate error is equal to previous approximation. We know that is previous approximation was 2.8233 and revised approximation is 2.7987. So 2.8233 minus revised approximation is 2.7987 divided by revised approximation is 2.7987 into 100. So this approximate error we get as 0.87%. So now true error we can calculate. Revised approximation is 7987. True value is known. So revised approximation 2.7987 minus true value of this root, which is known to us, that is 2.798386.046 divided by true root 2.798386.046 into 100. So on simplification this works out as 0.011%. So approximate error is 0.87% and true error is 0.011%. So we can substitute it in this table. So approximate error is 0.87% and true error is 0.011%. So now this revised approximation we take here 2.7987. So now substituting this in this function f of x is equal to x sin x plus of cos x. So x value we are going to substitute as, now x is equal to 2.7987. F of x is equal to 2.7987 sine 2.7987 plus of cos 2.7987. So this works out as minus 0.000827, and f dash of x, which is nothing but x cos x. So substituting x value as 2.7987 cos of 2.7987. On simplification we get this as minus 2.6358. So revised approximation xn plus 1 is equal to previous approximation, that is x naught minus of f of x divided by f dash of x. So x naught value here is 2.7987 minus of f of x. This is negative, f dash of x is negative, so it becomes positive. Negative becomes positive. 0.000827 divided by 2.6358. On simplification we get this as 2.798386.243. So this is about the revised approximation. So approximate error can be obtained now. So previous approximation was 2.7987 minus of revised approximation is 2.7987 2.798386 divided by a revised approximation 2.798386 into 100. So this is new root which we obtained, a revised approximation. So on simplification we get this as error as 2.5 into 10 to the power of this we get as 0.011%, and then true error is equal to, the revised approximation is 2.798386243 minus true value of this root is 2.798386046 divided by 2.7983866046 into 100. So this is equal to, true error is 7.03 into 10 to the power of -6. So this error is so small. So now we can substitute these values in this table. The function value we get as -0.000827. Function value which we obtained is -0.00827. So derivative of that is -2.6358 minus 2.6358. Then the revised approximation we get as 2.7983866243, and approximate error we get as 0.011, and true error we get as 7.03 into 10 to the power of -6, which is very small. We can stop here, or else we can proceed one more step beyond this. So at this stage we can stop, and because this error is less than 0.5 and this error is very less, so we can stop here, and we can write answer for this. The root of function f of x is equal to x sin x plus of cos x is 2.7983866243 with approximate error of 0.011% and true error of 7.03 into 10 to the power of -6%. 10 to the power of -6%. So this is the answer for this. Even if you go beyond this, you will reduce the error. So there will be very minor change in this answer. So this was about the methods of finding roots of equation. So earlier we have studied bisection method, which was known as a bracketing method. So in bracketing method, what we studied, so this is the number line. We initially used lower limit xl and xu, which is on either side of a root. So this is the root, true root xt. So gradually we move from upper limit as well as lower limit, and finally we capture this true root of this function, that is known as a bisection method or bracketing method. And in case of Newton Raphson method, if this is the line, so either we are going to take xl and say for example xt is here, gradually we are moving from xl to xt. So here we are moving in both the directions from upper limit and lower limit, where function is, for example, f of x is positive and f of x is negative. So it was between positive and negative, so root was lying between positive and negative. But here, so there is no question of positive or negative. So first we take initial approximation and then we refine this initial approximation to final true answer. So gradually we reach towards true root of this function. So that is known as open method. So here this is open because it is not closed by the boundary limits. So here in Newton Raphson method, we are going to find this answer or root of this equation by taking one of the approximation and refining this approximation gradually to reach the root of this function. So now we are moving to numerical solution to algebraic equation. So what is algebraic equation? Say for example, a11 x1 plus of a12 x2 plus of a13 x3 plus of so on plus of a1n xn is equal to c1. So this is one algebraic equation which has got n constants and n variables 1 to n. So we may have another algebraic equations a21 x1 plus of a22 x2 plus of a23 x3 plus so on plus a2n xn is equal to c2. So this is second equation, and so on. We may have many more equations, and finally we may write this as a n1 x1 plus of a n2 x2 plus of a n3 x3 plus of dash dash plus a n xn is equal to cn. So this is nth equation. What we have here is we have n equations and n variables. So these simultaneous equations can be solved with each other, and we can find root of the values of variables, that is x1 x2 x3 and so on up to xn. So by solving these simultaneous equations, we can get the root of the values of these variables x1 to xn. So let us see one example. That example is, say, example is here. Say this is 3x1 plus of 2x2 is equal to 18. This is one equation, algebraic equation, and second algebraic equation is minus x1 plus of 2x2 is equal to 2. So this is second algebraic equation. So we can simplify these two algebraic equations, and once we simplify these two algebraic equations, we get x1 is equal to 4 and x2 is equal to 3. So by simplification of these two equations, we get this x1 is equal to 4 and x2 is equal to 3. How we get it? Just if we take 3x1 plus of 2x2 is equal to 18 and minus of x1 plus of 2x2 is equal to 2. So multiplying second equation by minus 1, we get this as plus x1 and minus 2x2 is equal to minus 2. So this is equation number 1, and we call this as equation number 2. Adding equation 1 and 2. So here 3x1 plus x1 is 4x1, and this minus 2x2 gets cancelled with plus 2x2. This is going to be 0. Plus 0 is equal to 18 minus 2 is 16. So x1 4x1 is equal to 16 or x1 is equal to 4. So substituting x1 is equal to 4 in one or either of equation. So if we substitute in second equation, minus x1 plus of 2x2 is equal to 2. So minus 4 plus of 2x2 is equal to 2. So this on simplification becomes 2x2 is equal to 2 plus this minus 4 on right hand side. If we transfer, it becomes plus 4, so 6. So x2 is equal to 3. So x1 is equal to 4 and x2 is equal to 3. This we can simplify and get it. So now we'll solve this these two simultaneous equations graphically, and what it signifies that we'll see. Say, let us see 3x1 plus of 2x2 is equal to 18. So if I substitute x1 is equal to 0 in above equation, so this becomes 2x2 is equal to 18 and yields x2 as 9. That is nothing but when x1 is equal to 0, x2 is equal to 9. So now if I substitute in this equation 3x1 plus 2x2 is equal to 18 as x2 is equal to 0, then 3x1 is equal to 18, and this results into x1 is equal to 6. That is nothing but when x1 is equal to 6, x2 is equal to 0. So this gives us coordinate A and coordinate B. So we obtained coordinate at point A and coordinate at point B for this same line 3x1 plus x2 is equal to 18. So this line has to pass through these 2 points A and B, then we get this line. So second, we take another equation, that is minus x1 plus 2x2 is equal to 2. So substituting x1 is equal to 0 in this equation, we get 2x2 is equal to 2, or this results into x2 is equal to 1. That is nothing but when x1 is equal to 0, x2 is equal to 1, so we get point C6. So now we substitute x2 is equal to 0 in this equation number 2. So if we substitute x2 is equal to 0, minus x1 is equal to 2, or x1 is equal to minus 2, we get. So x1 is equal to minus 2. So we can write as minus 2 comma 0. So this point we call as a D. So we obtain point A for first line, that is 0 comma 9, and point B as 6 comma 0 for first line. And then point C as 0 comma 1 and point D as minus 2 comma 0 for second equation. So taking this, if we plot graph, what are these points? A09, A09 and B60 for first line, and for second line C is 01, C is 01 and D is minus 20, minus 20 for second. So we plot this on the graph. If we take graph, okay. So now we take this as 1, 2, 3, 4, 5, 6, 7, 8 and 9 on x2, and we take x1 on this x-axis, 1, 2, 3, 4, 5, 6, 7, -1, -2, -1, -2, -3. Now we take point A, 0, 9. x1 is equal to 0 and x2 is equal to 9, means this point A is here. Point A. Point B is x1 is equal to 6 and x2 is equal to 0. So this point is B. So now if we join these two lines, these 2 points, we get one line like this is passing to point A and B. So this is first line for first equation for set of coordinates 0, 9 and 6B. So this point A and this is point B. For line which is that first line 3x1 plus 2x2. This is for 3x1 plus 2x2 is equal to 18. So this is the equation of this line. Now taking second line, C is 0, 1. 0, 1 means here x1 is 0 and x2 is 1. So this point is C. And point D is -2, 0, -2 and 0. So -2, 0, this is point D. So if we take another line passing through C and D, we'll extend this line. So these two lines intersect somewhere here. Exactly, if we take graph paper and simplify this, so this is going to intersect at point 3, approximately here. So this is x2 value is 3 and x1 value is 4. That is, coordinates of this point are 4, 3. So if we see the solution of this problem, what we obtained here, x1 is equal to 4, x2 is equal to 3. So graphically also we obtained x1 is equal to 4 and x2 is equal to 3. If you take graph paper and simplify this on graph paper, then we get this answer for intersection of these two lines, say A, B, C, D, E. Point E is the intersection and coordinates of this point E will be 4, 3. And this is the equation for line second line is minus x1 plus 2x2 minus x1 plus 2x2 is equal to 2. So for this line, so this is the point of intersection where we obtain the coordinates of that point as 4 and 3, means x1 value is 4 and x2 value is 3. But this is not possible for the set of equations which contain more than 2 variables. So at that time we have to use certain methods which will find the solution to n number of simultaneous equations having n variables. So now we will have the conditions, say, or this 9 is called as y-intercept for first line, and for second line we call this as 1 point as intercept of second line. So this is how we find these two equations. So or else this line equation as, if we see 3x1 plus of 2x2 is equal to 18. So this can be written as 2x2 is equal to minus 3x1 plus 18, or x2 is equal to minus 3 by 2 x1 plus of 18 by 2 means 9. So this 9 is y-intercept, or we call as x2 intercept, and minus 3 by 2 is the slope of this first line. Slope of first line is minus 3 by 2, and 9 is the x2 intercept. We call 9 as x2 intercept. Similarly, if we write second equation, that is minus x1 plus of 2x2 is equal to 2. So on simplification, 2x2 is equal to x1 plus of 2 or x2 is equal to 1 by 2 x1 plus 1. So 1 by 2 is the slope and 1 is the intercept. So this 1 is the intercept and slope of this line is 1 by 2. So slope is 1 by 2 and intercept is 1. So this is how we find the solution for simultaneous equations, algebraic equations. Now we'll see certain conditions. What happens? There are two equations of line. So first equation we write here as x2 x1. First line equation is minus 1 by 2 x1 plus of x2 is equal to 1, and another equation of line is minus 1 by 2 x1 plus of x2 is equal to 1 by 2. So these are the two equations, equation number 1 and equation number 2. If we plot this on graph, then we find that these two lines are parallel. So when lines are parallel, not intersecting with each other, we cannot find solution for these two equations. So this has got no solution. No solution for such parallel lines. If two lines intersect, then we can find out intersection point, and from that we can find out coordinates of this point of intersection, and that will be the solution for two simultaneous equations. Now second condition, if we see x2 x1, so here you can find two lines are overlapping, so same lines are going to overlap. So here we write equation as minus 1 by 2 x1 plus x2 is equal to 1, and another line which we call as a minus x1 plus of 2x2 is equal to 2. So these two lines are going to overlap. In this case, infinite number of solutions, because these two lines are going to overlap with each other, means these two lines are intersecting at each and every point. So for such set of equations, we get infinite solutions. We get infinite solutions because two lines are going to intersect or going to overlap with each other. Therefore, at every point over this line, there is an intersection, and every point will be the solution for these two simultaneous equation number 1 and equation number 2. Now we'll have another set of equation. So here we have two equations, that is 23 minus 23 divided by 5 x1, or 2.3 minus 2.3 divided by 5 x1 plus of x2 is equal to 1.1. This is one equation, and another equation is minus 1 by 2 x1 plus of x2 which is equal to 1. So here you find two lines. So two lines are going to overlap or intersect at one point, but this point of intersection is not clear, whether it is intersecting here or whether it is intersecting here or whether it is intersecting here. So if we plot it on graph paper, it is very difficult for us to find out exact point of intersection in this case. If two lines are intersecting in this way, we can find out point of intersection, but in this case point of intersection may be in between these two. So here we can find the solution, but the solution which we obtain will not be more accurate, and such condition is known as a ill condition. We call this as a ill condition. In case of ill condition, these two equations of line are very similar to each other. So if you divide it 2.3 by 5, it will be approximately minus 1 by 2, and this 1.1 is approximately equal to 1. So these two equations are going to be very similar. At that time, two lines are going to intersect, or approximately the slope is very same. So in these two cases, if we simplify, slope is going to be very same. So here, if we write this first equation, say this is x2 is equal to 2.3 divided by 5 x1 plus of 1.1. So this 2.3 divided by 5 is slope of first line, and in second line x2 is equal to 1 by 2 x1 plus of 1, this 1 by 2. So 1 by 2 is very close to 2.3 divided by 5. So slopes are very close to each other, and these two lines are going to overlap to some extent, but not completely. This is not having infinite solution, but the solution which we obtain graphically will be very much confusing, and this condition is known as the ill condition of equations. So to find the solution for two equations or many more equations, algebraic equations, if these are intersecting clearly, the point of intersection can be obtained, and that gives us solution, exact solution. But if two lines are parallel, whenever it is possible to get the solution. If two lines are going to overlap, then it has got infinite solutions. And if two lines have same slope or slope very close to each other, then such kind of set of equations are known as ill conditions. So rest of the things on numerical solution to algebraic equations we will discuss in next class. We stop here. Thank you.